We're going to throw some secants and tangents here in the mix in section 8.3.4 as we consider integrals that contain products of powers of secant and tangent. Now, when we started section 8.3, I mentioned it's really important that you have a working knowledge of the basic fundamental formulas because we'll be building on those formulas. A few formulas that will be vital to this particular section are, first of all, a couple of derivative formulas and then also a Pythagorean identity. So let me just remind you, the derivative with respect to x of tangent of x is secant squared of x, that's from calculus 1, and the derivative with respect to x of secant of x is secant of x times tangent of x, also from calculus 1. In addition to recognizing these derivatives, we also need to know the Pythagorean identity, 1 plus tangent squared of x is equal to secant squared of x, or any rearrangement of that formula. So when we integrate products of powers of tangent and secant, we're going to look for certain categories. The first one we're going to look for is an even power of secant. If the integrand contains an even power of secant, then the strategy or key to finding the antiderivative is to split off a secant squared of x. I'm going to save this for the du term, and then I'm going to convert the remaining secants to tangent using that Pythagorean identity. And keep in mind, this is one option for working such a problem. So in example 5, we have the integral of tangent squared of x times secant to the fourth of dx times dx. So I'm going to focus on that even power of secant. I'm going to save a secant squared for du. And remember, if I'm saving this as a du, if this is going to be my du, that means u is going to be tangent. So I'm going to save a secant squared for du, and then I'm going to convert everything else to tangent. So we're going to rewrite this first as the integral of tangent squared of x times secant squared of x, secant squared of x dx. Now I'm going to save this for du, reserve for du. If that's du, then we know that u is going to be tangent. So even if you want to go ahead and write that down so you know where we're going, you're planning ahead, you have a goal, so we're going to take the steps to achieve that goal, then u eventually is going to be tangent. So we know that this first factor will be rewritten as u squared, but we do need to convert this to tangent because we can't have du times du, right? We don't have dx times dx. So let's convert that secant squared to the function tangent using our Pythagorean identity. Our integral will look like tangent squared of x, secant squared gets replaced with 1 plus tangent squared of x, and we're saving this secant squared of x dx on the end for du. Let's go ahead and rewrite this entire integral now in terms of u. We're going to end up with the integral of u squared times 1 plus u squared du. As a reminder, if you go ahead and distribute your tangent right here, no harm done. I simply prefer to make the substitution and then distribute the u squared simply because it's a little easier to deal with. So let's distribute to get u squared plus u to the fourth du. The good news is that's a polynomial, and integrating a polynomial is a piece of cake. So we have 1/3 u cubed. Remember, you drop your integral sign when you actually execute the antiderivative, plus 1/5 u to the fifth, and we're ready for our plus c. The last step, as always, is to go back and recover your original variable. Remember, u is equal to tangent of x, so I can rewrite this as tangent cubed of x plus 1/5 tangent to the fifth of x plus c. So we have successfully found the antiderivative. So the big idea there is we saw an even power of secant. So we split off a secant squared of x because we know that this is the relationship between secant squared and tangent as far as derivatives go. So if we save a secant squared of x, then we can make the substitution u equals tangent of x. So the only additional thing that we had to consider was converting the remaining secant squared to tangent squared using our Pythagorean identity. Now, another category that we may run into is when we have an odd power of tangent. If that's the case, one strategy is to split off a secant of x times tangent of x factor. Again, we're going to reserve that for du, and if that's du, that means u must be secant. Because recall, the derivative with respect to x of secant of x is secant of x times tangent of x. So in the case where we have an odd power of tangent, I'm going to split off a secant of x times tangent of x, and then I'm going to convert the remaining tangents to secant. Now that process is pretty straightforward, but on example 6, it gets a little bit tricky. So watch closely. We have the integral of tangent cubed of x divided by secant of x dx. So we do have an odd power of tangent, and that's what I'm going to focus on. But we don't really have the opportunity to split off a secant of x because the secant of x is in the denominator. So we're going to do a little bit of algebraic calisthenics here to prepare for our integration process. So the first thing I'm going to do is get that secant of x out of the denominator. I'm going to rewrite it as secant to the negative 1 of x dx. Now, if I'm going to let u be secant of x, then I'm going to need that secant of x, tangent of x term. So I'm going to rewrite my integrand as tangent cubed of x. Now watch closely here. I'm going to write secant to the negative 2 of x. So I'm changing that factor. Now, I can't just change the exponent to make the problem easier. I have to make sure that the integrand that I'm creating here is equivalent to the integrand in the previous line. And the way to do that is to go ahead and multiply by a secant of x. Notice if we do secant to the negative 2 times secant of x, if we add the exponents on the secants, we will obtain a net exponent of negative 1. So line 2 is still equivalent to line 1. That gets me the secant of x that I need in the problem. Now, the next thing I'm going to do is split off a tangent of x from that odd power of tangent. So this is going to become tangent squared of x. I'm going to save that other tangent of x for the very end of my integrand here. Secant to the negative 2 of x, secant of x. Now here comes the tangent that I split off from that odd power. So here is the secant of x, tangent of x that I'm going to reserve for du. Now notice, eventually my plan is to let u be secant of x, so that du covers up this secant of x, tangent of x dx term. But in order to write my integral in terms of u, notice this term will be replaced with u to the negative 2, but this is also going to need to be in terms of secant. But that's no problem because we have the Pythagorean identity. 1 plus tangent squared of x is equal to secant squared of x. Now in this case, I do need to rearrange this formula as by isolating tangent squared, and we have secant squared of x minus 1. So I'm going to replace this with its equivalent in terms of secant. It's going to look like the integral of secant squared of x minus 1, and then all the rest of this junk is going to stay the same for this step. So now, in terms of u, this part will be u squared minus 1. This will be u to the negative 2, and all this good stuff will be du. Now, in order to work a problem like this, you really have to look ahead a little bit. Where am I going? What terms am I going to need? How do you develop those skills? Well, first of all, you study the individual categories and determine what's the plan or the algorithm or the process for that particular situation. And then you practice, and practice makes perfect, right? So at this point, we need to write the entire integral in terms of u. So we have the integral of u squared minus 1 times u to the negative 2 du. Now, I'm really liking this. This is going to be easy to integrate. Let's go ahead and distribute our u to the negative 2 term. U squared times u to the negative 2. If I add those exponents, I get a 0 exponent. U to the 0th power is 1. And negative 1 times u to the negative 2, of course, is u to the negative 2. Now we're ready to actually integrate. We've been doing lots of preparation. Now we're ready for the integration. The integral of 1 with respect to u is u. Applying the power rule to this term, we're going to have u to the negative 1 divided by negative 1 plus c. Let's go ahead and clean up that second term. Notice we have a double negative. We can call that a positive. And let's execute that negative exponent and put that in the denominator. So the very last thing that we need to do is go back and recover our original variable x. And we can express the result as u, which is secant of x, plus 1 over u, or 1 over secant of x plus c. Now, you want to leave it like that? I don't really. I can see a way to simplify it. Are you looking at what I'm looking at? Let's rewrite that 1 over secant of x as cosine of x. And of course, we have our plus c there on the end. So we have successfully integrated a complicated trig integrand. So at this point, we have studied two different cases. We have looked at what happens when we have an even power of secant and an odd power of tangent. So you may be thinking, well, what happens if I have both situations? Well, in the case of both situations, you can choose either of those methods. Your final integrand may be different. For example, it may come out in terms of tangent instead of in terms of secant, but you could use trig identities to prove the equivalency of the two different formats. So if you have both of those situations, then choose a method. We're going to go ahead and finish off this section with what I'm calling a challenge problem. Notice example 7, we have an odd power of secant, but this is not so much as a challenge problem as a rite of passage. Integrating secant cubed of x is a fundamental calculus 2 problem that will follow you throughout calculus 3 and differential equations. Integrating secant cubed of x requires integration skills that we've previously learned. So let's see how we're going to handle this one. The first thing I'm going to do is simply to split up this integrand into the product of secant of x and secant squared of x. Now, looking at the two factors in our integrand, we see our secant squared of x. We know that that is the derivative, an easily recognizable derivative of the function tangent. As far as the other factor, secant, we don't recognize secant to be the derivative of a common function, but we know that we can differentiate it. So, do you know where I'm going with this? We're actually going to execute this using integration by parts. That is, we're going to let IBP, we're going to let u equal secant of x because it has an easily recognizable derivative, right? Secant of x times tangent of x. And then we'll let dv be secant squared of x dx because it has an easily recognizable antiderivative. So applying our integration by parts formula, we have u times v, that's secant of x times tangent of x, minus the integral of voodoo, right? V du. Now, if I multiply tangent of x times secant tangent, I'm going to end up with tangent squared of x times secant of x dx. So now we have an even power of tangent and an odd power of secant. Notice this integral doesn't fit either of the categories that we studied in sections A or B. So what are we going to do now? Well, we're going to resort to our Pythagorean identity. Recall that 1 plus tangent squared of x is secant squared of x. So I'm going to use this Pythagorean identity to convert everything in the integrand to a single trig function. So I'm going to replace tangent squared of x with secant squared of x minus 1. Our integral becomes secant of x, tangent of x. Now those two terms have been integrated already. No pending integration there. Minus the integral of, we're going to replace tangent squared of x with secant squared of x minus 1. And we still have this secant of x dx hanging out here. Then I'm going to go ahead and distribute the secant of x. So we have secant of x times tangent of x minus the integral of secant cubed of x minus secant of x dx. Now, are we getting anywhere? Let's go ahead and split that integral into two separate integrals, and maybe you'll recognize what the next appropriate step is. So we have secant of x times tangent of x minus the integral of secant cubed of x dx. Now be careful here, we're distributing the negative, so we're going to get plus the integral of secant of x dx. So looking at executing the two remaining integrals, notice this one is a new formula that we have learned. Recall that the integral of secant of x is the natural log of the absolute value of secant of x plus tangent of x. So that's one of our new formulas. Remember, you now have a formula for integrating all 6 of your basic trig functions. So I'm going to be able to handle that one easily. But do you notice what we have right here? We have reproduced the original integral. We saw this previously with our integration by parts process. So what I want to do is actually solve for the integral of secant cubed. So for convenience and to remind you, we do have a left side over here. I'm going to go ahead and bring this down. Then we're going to add the integral of secant cubed of x to both sides. Essentially, we're going to solve for it algebraically. So on the left side, we have the integral of secant cubed plus the integral of secant cubed. That gives me 2 times the integral of secant cubed of x dx. Then we have this term, secant of x times tangent of x. Now remember, this integral went away, so those are going to cancel. And we've discussed, we do have a formula for integrating secant. It's the natural log of the absolute value of secant of x plus tangent of x plus c. Now we're almost there. The original problem was to find the integral of secant cubed. At this point, I have twice the integral of secant cubed, so we do need to go ahead and multiply both sides by 1/2 in order to solve for our original problem. So we end up with the integral of secant cubed of x dx equals, and I'm just going to distribute the 1/2, 1/2 secant of x tangent of x plus 1/2 natural log of the absolute value of secant of x plus tangent of x. And here, if we distribute the 1/2 to the constant, 1/2 times the constant is a constant. Whew, and we have integrated secant cubed of x. Now don't forget this problem. It will come back to haunt you in both Calculus 3 and differential equations. Remember, to integrate secant cubed, we use the sneaky process of integration by parts. And of course, in there we have to know the derivatives and integrals of individual trig functions as well as our trigonometric identities. So congratulations, you just went through a rite of passage for Calculus 2.